Yes! 80s one-hit wonder throwback. Rick Astley's Never Gonna Give You Up. I don't even know how it ties to today's lesson. Usually I like to tie it into the lesson, but I was just feeling a little Rick Astley. I'd get in front of the camera and dance, but right now I'm dancing. I'm having too much fun dancing behind the camera. I've really got it going on here. Oh, tell me how I'm feeling. That's how it ties to the lesson. I'm going to tell you how I'm feeling. Never going to make you cry. Oh, man, what causes pain anyway? Oh, boy. I knew it tied to the lesson somehow. I just had to figure it out. All right, today, welcome back. Here we go. It's neuropsychology again. This time we're finishing up the last lesson. We're into unit 2.2. And our last class, we talked about the neuron. And I left the drawing of the neuron down here because the neuron is going to interact with our other peripheral nervous system device, the endocrine system, which is today's lesson. And I left the drawing down here because we're going to see how that reacts here in a moment. Okay, so neuropsych is basically the idea, just to recap from yesterday, that all behavior starts and ends with biology. And that a lot of our behaviors and thoughts and feelings and actions can all be described through biological processes in this nervous system. So today we want to focus on the endocrine system. And the endocrine system is the system that allows for hormonal secretion. So it secretes hormones and other neurotransmitter chemicals. Give me a second. Remember, if it's on the board, it's in your notes. Make sure you're taking the notes here. And here's the goal of this endocrine system. The goal is to create something known as homeostasis, which we'll maybe get into a little bit more here in a moment after we describe how the system works. We can come back and understand what we're talking about by a balanced state. The other goal of this endocrine system is to react to stimuli, right? To react in real time to different stimuli that are occurring to our body. You know, for instance, being set on fire, got to react to that. You got to have a reaction when you're lit on fire. Okay? So the endocrine system is going to work through a whole series of glands. We're not going to worry about what those glands are specifically. This is an intro course, right? This is high school intro course. We are not going to get into like every little nitty-gritty piece of the brain, or we're not going to label every single gland in your body. We're going to save that probably until you get to college. If we offered AP Psych, we'd be doing it, but we don't. This is just an intro high school course. So what we've got going on here, and I've drawn the glands as these like giant water buckets, for lack of a better analogy. And I drew them like that for a specific reason. And that is, they hold, right? We can imagine each gland as holding a certain level, which I'll draw as water in a water bucket. Now, it's not water, though. It's going to be these neurotransmitter chemicals and hormones. And we're going to draw maybe different levels. Geez, I should fill this guy up, right? And like each hormone, right? These holding tanks are going to, these glands are going to produce these neurotransmitter chemicals, and the glands act as holding tanks of different levels of those chemicals. Now, not only do you have the ability to produce these chemicals, I also like this analogy, and it's kind of like a homegrown analogy because it makes sense to me, and I think it's going to make sense to you, even though it's not like specifically exactly, again, if it were an AP course, it's not exactly how it works, but this is going to get the point across really well. And that is that these glands sort of control the stream. Not only do you have a production level, but you also have a release level. So I could take these spigots, and I could take the spigot, and I could turn the spigot all the way up, and I could also reduce the spigot down to just, a trickle of a drop or two, or I could go to like just a light trickle, something of that level. So the glands sort of control production level, and the glands control release level. Okay, and that's going to be important to understanding what's going on here in a minute when we start to incorporate these hormones in with the way that the neuron worked. As far as what chemicals glands produce in your body, let's just focus on the big six. Okay, we're going to call these the big six. And these two specifically, when we get to those two, they kind of play a special role. So, big six hormones or chemicals that your body controls. Acetylcholine. Now, maybe you've even heard of, like, I bet you sometimes when you are in pain or when you're sore and your muscles are tight, you might take acetaminophen. Right? And there's that sort of same root word, base word. Acetylcholine is the hormone that controls your muscle contraction. So if your muscles are tight, right, that is because you have your neurons are registering a lot of, your Pac-Men are gobbling up a lot of acetylcholine, and that is creating muscle contraction. Okay, some other ones of the big six, dopamine, right? If you're all doped up, you are experiencing a great amount of pleasure, right? And that's almost become like a euphemism in our culture, to be doped up. That means you have a lot of dopamine hormone that is floating around, that is, triggering this neuron reaction, which we'll get to in a minute, how that sort of happens. We sort of alluded to it in our last class. And of course, if that charge occurs enough and it extends all the way down the axon, then that is what you're going to feel as that message is relayed from neuron to neuron. The other ones of the big six, endorphins cause like pain relief and euphoria. Serotonin is an antidepressant. It affects your mood greatly. If you are low on serotonin, if you have serotonin just out here as a trickle, right, then you tend to be extremely in a bad mood. And if your serotonin is gushing out, then you'd be like on a high or a great mood. You might feel wonderful. And so each of these, right, endorphins, I think we already covered that one. Your endorphins cover your like pain relief and euphoric feelings. So not only do you have those feelings that are kind of being ushered in through these chemical hormones, but you also have some inhibitors and exciters. So let's get to our neuron here and kind of like think about how this is going to work. Let me get some black. I need my black and my blue marker. So let's just take, for instance, like the inhibitor GABA, and that is a long, again, if this was AP Psych, we'd have to really probably know what this is. We're just going to think of it as an acid. Okay, this is an acid in your body, right? And the way it's going to work as an inhibitor is I get my Pac-Man over here, and we talked about this a little bit yesterday, that these terminal buttons, when a message reaches the terminal buttons, it fires a synapses, this little electric lightning bolt, right? And that little electric lightning bolt is going to activate, I'm drawing it in black, but really it's these hormones. And then these hormones are kind of floating, and Pac-Man goes around and gobbles it up. The next Pac-Man on the next neuron is going to gobble up those hormones, and that is going to cause, again, a reaction down the axon until the next neuron fires that same message, and the neurons are communicating this message one shot at a time from neuron to neuron. An inhibitor would work like this. Imagine if we took Pac-Man here, and instead of the hormones that it's gobbling up, imagine if we took Pac-Man and just stuffed his mouth with like a big blocker. Well, now my dendrite, my Pac-Man here, can't gobble up these hormones. And so this is one way in which your body can kind of control the balance level of what's going on. Your body might be producing a whole ton of a certain hormone, and it might be in the system ready for these synapses to hit and fire and for the dendrites to gobble up and that message to get passed on. But if Pac-Man is inhibited from gobbling up hormones, it doesn't really matter how much your gland's releasing, because Pac-Man can't gobble it up, right? If you want to think of it like that. Now, conversely, we have glutamate, and glutamate is an exciter. So glutamate is going to interact with Pac-Man here, and it's going to send Pac-Man on a crazy gobble mission, where even if like you're producing a trickle of a certain hormone, Pac-Man's gonna gobble, 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 and start chewing through, right, the level of that hormone that you've produced. And so you have inhibitors, and you have exciters, and you have these different holding tanks of these different chemicals. And what this idea of homeostasis is that your body is constantly sort of inhibiting and then exciting and turning the valve open and turning the valve closed and turning the valve all the way open, right? And producing higher levels in the holding tanks or lower levels in the holding tanks, right? Like, oh, geez, this one's almost dry over here, you know? And your body's constantly going through this whole shift of filling tanks and turning the knobs on these hormones and blocking the dendrite Pac-Man and exciting the dendrite Pac-Man, all in an effort to achieve this balanced state. And this is not the first or the last time I'm going to draw this, but if we think of a balanced state as like, here I feel fine, and here I feel lousy, and what this endocrine system really does, the main goal is to achieve that balanced state. And so for most of us, we probably sort of like hover in this range, okay, over time. If I look over time, right, the body might turn up or fill the level of one of these hormones that makes me feel really good. And then the body might be like, okay, well, this is like, I'm kind of going overboard with this. And so we're going to take some GABA inhibitors. We're going to block Pac-Man from gobbling that up. Or maybe we're going to turn the faucet down on that sucker, right? And the body is constantly, so yeah, I feel really good. But the body's like, oh, it's a little too much, and turns it down, a little higher, a little lower. But it's really kind of a tight range that body sort of wants to stay in. That is the homeostasis of that balanced state. Now, this is going to really be helpful. This is kind of a game changer when it comes to understanding what's even happening to yourself. We get these mood swings, especially puberty. We're not at the part of it, we're not really in the lesson about human development, but we can see things coming now, hopefully, right? With an introductory lesson like this, we can start to understand something like puberty, where my brain is literally freaking out over every little thing, and I'm very uneven with my mood. Why? Because my body is starting to produce these hormones, and it hasn't quite figured out how to regulate it yet. And so maybe someone going through puberty, right, they might experience something like this, right? It's not a nice rolling homeostasis, and then maybe even once in a while, oh, yikes, like, oh boy, I'm in a really, really bad mood today. Okay, and we've got that type of stuff going on in our body all the time, and it's about regulation. It's also, right, a lesson like this is going to also open up the gateway to understanding stuff like depression, right, and mood-altering drugs, and sort of like the psycho-altering drugs. This is all going to make sense. Almost all of it's going to come back to this sort of biological understanding of the way that your endocrine system is controlling your mood and your feelings in an attempt to be balanced, but it's not always successful at being balanced. Okay, that's it for today. Great, thanks for joining. You come back tomorrow. Let's see, what lesson do we have on the docket tomorrow? We're probably going to start to get into like the bigger neurosystem, right? Not this sort of peripheral nervous system, but we're probably actually talking about the brain and the spine a little bit. I will see you on the flip side.